Hi, I'm Adam. Welcome back to Godot Gamedev. In this video, we'll take a look at the Wrap2D component, which does exactly as the name suggests. Now, designing components can be easy as asking three very important questions. What is that one thing that the component does very well? What data is needed for the Wrap2D component to work? And finally, how does it communicate with the outside world? For the Wrap2D component, it wraps any Node2D derived node safely around the screen on the horizontal axis, the vertical axis, or both. An important side note here is that the Wrap2D component works for character body 2D and rigid body 2D nodes as well. So you can safely use it for any 2D node in Godot. Now, what data is needed for a Wrap2D component? The most important one is a target node to wrap around the screen, and we also have some configuration options like Boolean flags for enabling and disabling horizontal and vertical wrapping, and also a margin distance, which is the distance to pass beyond the screen edge before the wrapping occurs, so you don't cut the nodes in half before teleporting them to the other side of the screen. And finally, how does a Wrap2D component communicate with the outside world? This is a rare exception because this component does not need to communicate with the outside world. It handles the wrapping itself directly for the target node in the physics process virtual method. Now let's move on to implementation next. The component shows configuration warnings when there is no wrapping target selected. For this, the script needs to run inside the editor, hence the tool annotation. Then a custom icon is provided which makes the component feel like it's part of the Godot ecosystem when you add it to the scene tree. Finally, a custom class name is set and the class is extended from the base node class. Then an export variable is defined for the Node2D target. It defaults to the parent node of the Wrap2D component, but you can change this since it's an export variable. The custom setter function calls update configuration warnings after setting the new value, so the editor can check if the correct node type has been set for the variable. Then, two Boolean export variables are defined for vertical and horizontal wrapping. If true, the target node can wrap around the given axis. Then a margin value is also given, which provides a distance beyond the screen edge before the wrap occurs. It is given in pixels. Then we have a member variable where the current size of the viewport is cached and stored. This is useful because the screen size can change while the game is running, and we want the Wrap2D component to work after the screen size changes too. Inside ready, this is exactly what we do. We'll call a method we are yet to implement called update screen size, but we also grab the viewport with getViewport and connect to the size changed signal to the very same method we just called. Again, we are yet to implement this update screen size method. Next, we override the built-in getConfigurationWarnings virtual method. There are two cases to handle. If the target export variable is null or it's not a Node2D, we display a warning message. Otherwise, we return an empty array indicating that the Wrap2D component is configured properly. Next, we override the built-in physics process method. We start with a safety check. If we have no valid target currently, we don't need to do anything, so we can return early. Otherwise, we have two cases to handle. If the target is a rigid body 2D, we need to handle it differently because we cannot safely update its position during physics calculations. We have a different method called wrap_rigid_body to handle this specific use case for rigid body 2Ds. Of course, we are yet to implement this method. Otherwise, if it's not a rigid body 2D, we just update the global position of the target node based on the return value of a calculateWrap function, which again, we are yet to implement. This is the bulk of the logic. Now we just need to implement all the missing methods. First, we have update screen size. It's as easy as overriding that screen size member variable with getViewport.getVisibleRect.size. Again, this will be called twice, once when the Wrap2D node is ready in the scene tree, and every time when the viewport's size changes. Then we have calculateWrap, which is responsible for taking a vector to position and returning a new one based on the wrap logic that we need. First, we check if we can do horizontal wrapping, whether that Boolean flag is enabled or disabled. If it's enabled, then we can use wrapf to safely override the x position of the position vector. And the minimum value we can use is the negative margin, because 0 would be on the x, the left edge of the screen. But again, we provided extra margin, so the transition between the two edges is smoother. Applying the same logic, the limit for the right side of the screen is the screen size is x variable, which is the right edge of the screen, but again we add the margin, this time as a positive value, to provide it extra leeway when the wrapping occurs. Then we just do the same thing for the y-axis if wrap vertically is enabled. And finally, after the possible overrides of both the x and the y coordinates, we return that new modified position from the method. This method will be called directly for all non-rigid body 2D nodes, and it can handle wrapping just fine. The very final thing we need to do is the wrap rigid body method, which specifically handles rigid body 2D targets. The thing is, rigid body 2Ds can only be safely modified in terms of position before forces are applied to them by the physics engine. There is a built-in virtual method for that purpose, it's called integrate forces, but the problem is that Wrap2D is an external component that needs to modify the rigid body 2D from the outside. So we cannot override the integrate forces inside Wrap2D because it's just a node, it's not a rigid body 2D. So to simulate the behavior of the integrate forces method, we can get the same physics direct body state 2D object that integrate forces has as a parameter. To do that, we use the combination of rigidbody.getRID, which returns a unique identifier for that rigid body, and then we can query physics server 2D by calling the body get direct state method and passing that RID as a parameter. Now, it can happen that we don't have a valid state, so we have an if statement to make sure that we only execute any logic when we do get back a direct state from this call. And if there is a valid state, we need to do the wrapping, possibly, right? So what we do is we save the current position inside a variable and then get the new position by calling that same calculate wrap method we just implemented for non-rigid body 2Ds. And again, since we do that every physics frame, we can optimize the code a bit to only do the position override when the new position and the current position of the rigid body 2D don't match. Why? Because it can happen that we don't need to wrap the rigid body 2D around the screen yet. So in this case, we don't really want to modify anything if the new position that we calculated with the calculate wrap and the current position matches. But what if we do have to do the wrapping? This is where things get a bit tricky, because for these states, you can grab their transform, and their transform includes the position, the rotation, the scale, and the skew of that 2D object. And you can only modify the transform as a whole. You can't just override the position, which is called the origin in this case. So instead what we do is we grab state.transform, which is the current transform of that rigid body 2D, and save it in a new variable called new transform. And for the new transform, we can override the origin, which is the position, with the new position that we calculated above. This means that we don't change the rotation, the scale, and the skew of the object, only the position inside the 2D world. And when we're done with that, we can refer back to the current transform of that state object and override it with the new transform. So to summarize, first, a copy of the current transform is made, then the origin of the copy is set to the new wrapped position, and finally, the copy transform overrides the old transform of the state, wrapping the rigid body 2D safely around the screen. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now let's take a look at using the Wrap2D component in action. We have this scene set up where we have 3 different characters. We have one called character, which is this guy right here. And you can see that it's a character body 2D with an animated sprite, a collision shape, and a Wrap2D component added. For the Wrap2D, the target is set to the character body 2D. We set the margin to 32 because this character is 64 pixels wide. And if you take a look at the position, you can see that the sprite is centered horizontally. So we have 32 pixels on each side of the character, right? And with these values, this character can move from the left side of the screen to the right side by wrapping it around and vice versa. Now, to make this test scene easy as possible, I've just used buttons to control the character, so we can stop the character, we can run towards the left and run towards the right directions. Then we have a ball, which is a rigid body 2D. It has a sprite 2D, a collision shape, and a Wrap2D again, with the same settings that the character has, except of course for the target, which is set to the ball. And finally, we have a flying creature, which is the easiest one of the 3. It's just an animated sprite 2D to show that that with non-physics 2D objects, it still works fine. And for this one, the Wrap2D is set to wrap on the vertical axis and the target is set to the flying creature object. For the ball with the buttons, we can apply forces to it or reset its position to this starting position. And for the enemy, we can make it fly up or down. We have these buttons as scene unique names, and the only script we really need to do is inside the root node itself. Let's take a look at it. First, for testing purposes, we have a bunch of member variables. We have a speed for the character to run with, and we also have the current direction stored as a vector too. For the ball, we have the ball position, which is the starting position of the ball stored, and we have the impulses and offsets. So we have the force that we want to launch the ball with, and the offset is used to add a starting point to that force or a direction of the force, which means that from the ball's current position, we can add or subtract 32 on the x-axis to make sure that the impulse comes from the left or the right of the ball, depending on which button we click. And we have the same too for the flying creature, a direction vector and the speed variable. Now inside the ready, we store the current ball position when we run the scene, so we can reset the ball to that position if we click on the button. And then we have a bunch of one-liners connected to the buttons. So if the character left button is pressed, we change the direction vector to the left. If stop is pressed, we set it to 0. If right is pressed, we set it to right. And pretty much the same for the flying creature, but we use the up vector, 0 vector, and down vector depending on which button we clicked. For the ball, left and right are easy. We call the apply impulse method on the rigid body 2D, and we use the impulse and the offset vectors that we provided above. If we want to launch the ball towards the left, we need to apply the negative sign to them. The only exception where we do something differently is resetting the ball, because it's very similar to how we changed the origin inside the Wrap2D component itself. So it cannot be a one-liner, we need multiple lines for that, and that's why I used a different method for it. Now inside physics process is where we update the character and the flying creature, because they are character body 2Ds or just no 2Ds. So first for the character, if we have a direction that is either the left or the right, we play the run animation, we flip it. This could be changed with the flip2D component, but I want these components to be independent from each other, so that's why I re-implemented the flipping logic here, so you can test it on its own. Then we set the velocity based on the direction and the character speed, and call move and slide, which is an available method for character body 2Ds. But if the direction is 0, then we play the idle animation and reset the velocity to 0. For the flying creature, we do pretty much the same, but we can directly change its position since it's not a character body 2D. Based on the direction, the fly speed, and multiply it by delta to make it frame rate independent. And again, we play the fly animation if it's flying up or down, and play the idle animation if it's staying in place. And the very final thing we do is the reset ball method, which uses a pretty similar logic to what we did inside Wrap2D. We grab the state using physics server 2D.body get direct state and ball.get RID, and then we check if we have a valid state. If we do, in this case, we don't just change the origin back to the ball position that we stored in the ready, but we also change back the velocities to 0 to make sure that it starts falling again the same way. So any velocity that it accumulated will be reset as well. And that's pretty much it. It's just a bunch of testing code, really. If we go back to 2D view and see it in action, you can see that the forces are applied to the ball. It gets dropped by the gravity. We can start flying the enemy. And you can see that the margin works really well, because as soon as it disappears on one edge of the screen, it appears at the other end. If we fly it down, works the same way. We can stop it. The character does pretty much the same. When it disappears fully, it appears at the other edge of the screen. And the really fun part is actually launching the ball. You can see that the ball makes the character stuck because they can collide, which is perfectly fine. Now we start launching the ball. You can see that the forces are applied to it, but it still wraps around the edge of the screen. We can launch it the other direction as well. And it's super satisfying. We can click on reset, it gets dropped again with 0 velocity. And we can do all sorts of crazy stuff with it. And that pretty much wraps up the Wrap2D component, pun intended. That's it for this one, and I'll see you in the next one. Bye bye.